I've been 3D printing for a while, and I've done a lot of different things. But every once in a while, one of the things that I do is I relearn an old lesson. And a friend of mine helped me with this one. He damaged the side mirror on his vehicle. He struck a tree and it cracked the housing, and a small piece was lost. He asked me, "Hey, Brady, can you 3D print this?" And knowing what I do about printing, the answer is pretty much always yes. Question is, how long will it take and how much will it cost? So he gave me not the part that was lost, because obviously that's gone, but there was a sister part from the other side mirror that he popped off and handed to me. And my thought was, can I just scan this and then print it and be done? When it comes to the 3D scanning side of things, I know from experience it's mostly about the setup. And then once the setup is right, just let the system run, you'll get the scan, and then a little bit of post-processing, and I've got something I can 3D print. So I set up to scan. As you can see here, there's a spot in the middle that's all black where the scan should be. That's where the scan data should be showing up. And right now it's not showing up. So we've got a problem. What's going on here is that the black plastic is absorbing all of the infrared light. This scanner sends out infrared light very specifically and looks for the reflection back. That's how it creates the point cloud data to create the 3D model eventually. But without that light coming back, it can't detect anything and it can't build any point cloud, and we can't get a model. So this is not going to work. This automated scanning process is doing exactly what it's designed to do, but it's not able to detect what it isn't receiving. So here on the screen recording during the scan, you can see that there's no data. You can see on the left side that the scanner was properly aligned because the depth camera and the color camera are both recording nice clear images. There's just not enough light coming back. That's something we're going to have to fix. And something that's a little surprising is that I haven't really scanned anything black before. I know just from learning that black objects are notoriously difficult, and I've tended to avoid scanning them, and it just hasn't come up that I've had to scan one before, but now I do have to scan one. And fortunately, past me was thoughtful enough to put together a little bit of a trick spray that we use in the industry. It's a bottle of isopropyl alcohol with some powderized titanium oxide in it. Titanium oxide is really bright white, and it's going to reflect a ton of infrared back at us. So what we're going to do here is shake up the bottle and spray it all over the part. And we don't need a thick coat, we just need a thin coat. And as long as it's even, that's going to be getting us what we need. So after I give it some time to dry, I set it back up on the scanning rig and I start to scan. And here we're getting a great mesh. It's going from blue, which means points detected, to green, which means the automated process is working properly and we're getting usable data. So what I do from here is a few more scans to make sure I have an abundance of data, abundance of good scans. And then I adjusted the orientation of the object 90 degrees. So that way, the little clips that are on the object holding it up, they're in different spots for different scans. So that way the part that they were covering up will get scanned in the next set of scans. So what I did after that is I took the best scan from each orientation and I merged them together, and they overlap each other and they compensate for each other's gaps. And now there's enough data that I think we can go to a 3D mesh and export. And if I zoom in really closely here, you can see that although this looks solid on the screen, to the computer, to the software, this is a whole bunch of floating points in space that have very specific position and distance from each other. So that's kind of how the scanner gets this data from the real world, is it's taking a lot of 3D samples of points in space and identifying whether there is the edge of an object there or not. And when you take a whole lot of those really close together, like these are, the settings can vary, but here on this scan, I'm using it at 0.2 millimeters apart. So those little dots are 0.2 millimeters apart. Every millimeter, there's 5. So it's quite high detail. Yeah, I'm satisfied with this scan. It's worked out better than I expected. Here, we've got all the major geometry, so I'm ready to go to the next step. So here, I've got Bamboo Studio open, which is the slicing software that I like to use for most situations. For me, Bamboo Studio is going to work fantastically for this project. So I've already imported the file into the slicer, but remember that this is a one-to-one scan of that part that my friend handed me. So this part needs to be mirrored so that it matches the opposite side of the vehicle, because its features are all in alignment for the left side mirror. We need to create a copy for his right side mirror. So what I'm going to do is I'm going to mirror this object along the x-axis, which means all the features are going to swap sides. And it looks like it's done its job properly. This automated little tool is super useful, super powerful, and it's extremely reliable. From here, my next thought is that we need to add supports and then slice, which means to prep for printing. And what I'm looking for here is I'm making sure that the clips, the prongs, have proper orientation through the printing process, because the 3D printer lays down stack after stack of very, very flat layers, and it builds up the object out of that. If I put the object face down on the print bed and the prongs are facing up, they're liable to snap off relatively easily. I want them printing horizontally so that they're made up of very long lines and it can share strength through the rest of the part. That way, they're much less likely to snap off during usage, especially considering this is going to be on the vehicle. Now we're ready to print, and it's printing time. Oh, hey, for anybody eagle-eyed, you may have seen a mistake that I'm about to make. And bonus points to you if you see it. Comment down below. All right, we've got the print off of the printer. A couple hours have gone by, and now we have a new thing. This is probably my favorite part of 3D printing, where every day feels like a little bit of a Christmas gamble. Every time I press print, it's always a little bit of a new project. So I don't know if it's going to work or not. And now we have the part. So let's go find out. Let's get these supports off and see. And you know, right here, I'm noticing that there is an issue with this print. This part has gone unsupported, and this part needs support to properly form. So unfortunately, despite everything else looking pretty good, this print is a failure because this particular part is a critical part that needs to form properly. Let's go back into the slicer to fix it. So I'm back in the slicer, and I'm going to go into the manual support options to force the software to put support exactly where I know it needs to go. So here I'm working on the undersides of the prongs that were skipped. And this bottom prong did get support, but I want to extra make sure that it does on this second print also. So I'm adding supports there just to make sure. The reason I think that this prong didn't get support automatically is because of the threshold angle. When the underside of a slope has sufficient angle, supports won't be printed. And I think this prong may have just had enough of an incline that it didn't get support, even though I know and I wanted to have support while printing. So that angle is adjustable. Had I noticed that it wasn't properly supported, I could have adjusted that angle and the automatic supports would have picked it up. But there's more than one way to solve a problem most of the time. This one for me is exactly what I need. So I'm just going to paint it, tell it exactly where to put the stuff, and we're going to see how it works out. Time to print. Wow, so fast. If only if it was that fast in real life. Let's take a look, and it's already looking much nicer. The clips are fully formed. Yeah, there's nothing wrong here. This is pretty much all good. Yeah, we're good to go. I'm going to get these supports off. As I'm getting the supports off here, I'm noticing there was another area that didn't get properly supported. It may have been from material shrinkage. It may have been from the slicer not putting supports far enough up. It's not perfect. I'd give it, say, like a 98 out of 100 overall for this part. This is a cosmetic problem that I'll be able to file away, just like with a woodworking file. It's not a critical failure. It's more of an aesthetic cosmetic thing for this area of the model to have this kind of issue. On another print, it may be a failure, but on this print, it's an acceptable imperfection. So here we can see that the automated printing process has produced a functional part, but it's not perfectly optimized. When it comes to these prints, the final print quality and slicer setting choices are inseparable. We use profiles that tend to work most of the time, but every so often, even with a skilled operator going into it, we overlook something, or this part has just a little bit of a detail that's just in the right spot to trip up the automation in a way that we don't expect, but when we see it, we recognize what's happening and we know how to make the adjustments. So again, here, the automated processes need someone who knows what the end use part is going to need to have and can make choices about where to make sacrifices and where not to. All right. We've got a part. Supports are off, looking good. Here's our side-by-side comparison of the original panel along with the printed part. And we can see an incredibly high degree of accuracy in the recreation here. The geometry is exactly what it needs to be. I'm honestly expecting this to pop into place without any real tweaking or refining. Yeah, this is really good. Oh, I just sent the photos to my friend, and his original plan was to take this printed part and paint it black to match the black one. But he actually likes this clear white so much that he wants me to print a second one mirrored for the other side. So this print, he wants to replace the original part that we scan. So I don't really have to mirror anything because I still have the original scanned file loaded in the slicer. Because remember, we mirrored it and then printed from the mirrored object. We'll now print from the direct scanned file. I'll be making sure to paint those extra supports on. And we're going to have another one, a sister part, to match this one that we've just made. We've got the two printed parts along with the original. And aside from the writing that's on the inside of the injection molded panel, we've got pretty much an exact replica of the part and a mirrored replica of the part.
Wow, perfect fit.
And this project was a success because we have very powerful automated tools that do things people can't. I could not sit there and just by eye create a point cloud. I need an automated system to do that for me. But at the same time, that automated system needs me to aim it properly and set things up for it properly. Those automated supports do a ton of work. I would hate to go in there by hand and add in each support each time in each part for each print. That's just not realistic. But at the same time, they need me to double check them more thoroughly, especially for critical areas. And when it comes to choosing to override these automated systems or modify what they're doing, corrections need to be made by someone who understands the workflow, the necessary details the finished part has to have, and the wiggle room within the process. Because if we make changes too far, it'll disturb something somewhere else. And that's part of the fun of fabrication for me, is finding that solution as quickly as possible and as efficiently as possible. So the main core takeaway that I have for you today, the lesson I was reminded of, is that automated workflows do not understand function, and the operator has to understand function and make sure he sets things up properly for the best results in the end. Otherwise, we're wasting time, we're wasting material. So thank you for joining me. Feel free to subscribe, like, comment, and I'll see you again next time. Take care. Bye-bye.